All right, everyone. So we are officially kicking off our first our official AP Free Calculus Unit 1A. Okay. Unit 1A starts off with talking about change in tandem. Change in tandem, don't freak out. It's a new word, but it's just basically talking about how are we going from one point to the next, right? What's the rate? What's taking change? That's the overall gist of it. Our objectives are going to be to find the domain and range of a relation. Raise your hand if that's something you can do. Stating domain and range of a relation. I should see all hands up at this point. Okay. To determine if a relation is a function. How do we feel about that? Okay. Finding the domain of a function. Okay. Still not seeing a lot of hands. Getting a little concerned. Evaluating a function using both explicit and implicit forms. It means expanded or small version. So evaluating, if I give you this, can you do that? Okay. All right, identifying intervals of increase and decrease. So tell me when a function goes up, tell me when a function goes down. Okay, or if it's constant, points of inflection. Basically saying when does it change direction? When does the function change direction? And then finding the x and y intercept. That is the goal of our first section. Do these things sound doable? Yes? All right. So you should have picked up your notes. It's either not green, yellow or white paper. It folds and makes a little booklet so that when you put it in your notebook, you can glue the back in, right? So you should have this little guy, whether it's white or yellow. And this is part one. It's where we're going to begin. Got it? All right. Ta-da! So excited. All right. So we're going to first start off with function rules. Who would like to read that first sentence for us? Hit it.
A function is a mathematical relation that maps a set of input values to a set of output values, such that each input value is mapped to exactly one output value.
Perfect. So when we're referring to that, the main thing here is what makes a relation a function? X's cannot repeat. So don't go back to the past. No repeating X's, okay? So no or no. It didn't want me to write. It's cool. I didn't want to write anyway. All right. No repeating X's, right? All right, the set of input values is called the input values are your X's, and it's called the domain of the function. Good job, Randy. Domain of the function. Okay. The set of the output values is called the, don't know why that blank is so tiny. I don't know why it is. All right. Way back in Algebra 1, you guys may have heard of Dixie-Royd. D-I-X-I and Royd, R-O-Y-D. Dixie-Royd, domain, range, input, output, X value, Y value, independent, dependent. Okay? Those are all the different ways of saying domain and range. Dixie-Royd, two old dogs. Because I'm not an Algebra 1 teacher. I said way back in Algebra 1. You should have learned that. Okay. All right. The rule of 4 for when you are representing a function, there are 4 ways. It's like, nah, that's how some people say it. But GNAW, that means you can represent a function graphically, numerically, algebraically, and with words. Okay. Nah. Okay. Got it? So those are our 4 main representations: graphically, numerically, algebraically, and with words. And we have to be comfortable going in between those 4. Got it? Nope. We're big brains. We don't need a calculator right now. I'm sure. Why did my A disappear? Did I delete my A? Oh my gosh. My function disappeared, guys. It should say f of x equals 2x squared plus 5x. And for example A, it says f of x plus f of 3. All right, this is evaluating functions. So function notation was a big piece in algebra 2 and in algebra 1. Function notation basically means that you're doing what? Starts with the S.
Simplifying.
Well, it's two S's. You're substituting and simplifying, okay? Function notation means you're substituting and simplifying, okay? What's inside of the parentheses tells you what you're substituting in, correct?
Oh,
And then you're going to simplify from there, correct? So we're going to do the hard one together, and then I'm going to give you time to do B, C, and D at your table. Cool? All right, so up first, we have f of x plus f of 3. The first thing I have here is that f of 3, f of x isn't changing, right? It's whatever it is what I'm substituting in. What does f of x equal? 2x squared plus 5x. So I'm going to substitute in 2x squared plus 5x. Still with me? All right, on to the next. So plus f of 3. Well, f of 3 says that instead of an x, I'm replacing all of my x's with a 3. So now I'm writing plus 2 times 3 squared plus 5 times 3. So where there used to be an x, I've now substituted in a 3. So step 1 is to substitute. Good with substitution? Now we're on to the simplifying. Simplifying means I keep making it smaller and smaller until I can't anymore, right? Combining like terms, simplifying, reducing, and all that good stuff. So 2x squared can't do anything to right now. 5x doesn't need to be touched. But what is 2 times 3 squared? 18. And then 5 times 3 is? 15. Is that fully simplified? No. So I keep going. I can combine like terms. And we get 2x squared plus 5x plus 33. And that is my simplified term. Yes? All right. So guess who's starting this now? Yours. You're going to substitute, then simplify. Substitute, then simplify. All right. Get as much substitution done as you can. And then, if you hit a bump in the road, let me know. So just recapping, for B, we're replacing x with what? 2x. For C, we're replacing x with negative x. And for D, we're just only substitution. All right, here we go. So substitution. I'm replacing the x's with 2x, right? So now I'm working with 2 parentheses 2x squared plus 5 times 2x. Agreed? All right, now we're going to go through and use all of our rules that we've learned. So I'm going to distribute my power, and I'm going to distribute my coefficient. Oh, yes, okay. And distribute my power. So we have 2 times 2 squared is 4, x squared is x squared plus 5 times 2 is 10x. Is that fully simplified? No. 2 times 4 is 8. And that's all I can do.
So you threw me off because you said something. I was like, what you mean?
Oh, my bad. Okay, on the next one, we're replacing all of our x's with a negative x. So we have 2 negative x squared plus 5 times negative x. Okay, negative x squared means you now have 2 negative x's, right? And a negative times a negative makes a positive, so it's unchanged. But now I have 5 times negative x. And what does that make my 5 now? Negative, so it becomes minus 5x. You distribute PEMDAS. The E of PIM. All right, next. We're going to substitute. So everywhere x is, it now becomes x plus 3, right? So we have 2 parentheses x plus 3 squared plus 5 times x plus 3. Okay, the square, you have to deal with your exponent first. When you have a binomial square, that means you have 2 of them, right? You cannot distribute a power over addition and subtraction. Okay, you can't just go, oh, you get a square, you get a square. That doesn't work. That means that you have 2 times x plus 3 times x plus 3. Okay, and then you can distribute your 5, and we're left with plus 5x plus 15. And we have to do what? FOIL. FOIL. First, outside, inside, last. All right, so we're going to FOIL. I'm going to hold my 2 out to the end. So your first x times x is x squared. X times, if you distribute, yeah, I didn't distribute. I'll distribute in the end. X times 3 is 3x. That's my outside, inside. 3 times x is. And 3 times 3 is my last, which is 9. Okay, I'm going to now distribute my 2. Could I have distributed the 2 first and then FOIL? Yes. So I have 2x squared plus 6x plus 6x plus 18 plus 5x plus 15. And last but not least, I need to add, combine. 2x squared, does it have a friend? Nope. I have 6x, 6x, and 5x. That makes 17x. And I have 18 and 15, and that makes 33. Okay. So ponder, look over as I almost died right there. Were you have been quick enough to do that? I don't know.
See? Yeah, you got the wrong answer. You got 18 eggs plus something. Yo, don't talk to me. I was only one number wrong. I'm very wet. I just woke up. What is that? I woke up in my slumber. Yo, get this down.
I'm helping my girl.
Okay.
Homework.
Huh?
Homework.
Right here.
For homework.
Oh, you don't make me.
All right. How do you feel?
Is it too late to drop the class?
So ain't no way you dropping.
We haven't even did anything, Joel.
I never do my homework.
Ignore her. Friday. I'll be next. All right. Yes. Do we kind of remember this skill from Algebra 2?
Yes. This is like,
Okay. Yes. Okay.
Alberto demolished.
Now, if y'all see her, like my teacher never taught us that, I would be very mad as that teacher for the ones who had me, because we did. I said as the ones that had me. I'm not sure why my A's are disappearing. They're on your paper, right? Yeah. Okay. All right. So, what I'm going to do is I'm not going to go through this with you, because at this point you should be able to do domain and range without someone's assistance, right? So you're going to go through your table and you're going to quickly identify what's the domain and range of each function. However you want to do it, you can create a table, you can list it out, but you're stating what is the domain of all the different representation. So the first set you're given is ordered pairs. So looking at the ordered pairs that you have, I'm going to write them down really quick. So your ordered pairs, you have a set and it says 7, -2. Then you have -3, 5. And then you have 1, 6, and 3, -4. And you have 2, 5. Okay, this is a discrete data set, which means that because it is a discrete data set, when you're listing out, when you're stating your domain and range, you have to list them out. Okay, when you're listing them out, they need to be in either increasing order or decreasing order. Doesn't really matter which one. They're just supposed to be in some type of numerical order. Does that make sense? So well, let's do it together. We'll do domain first, and then we'll go. So domain here is, it means that we're looking at which variable? X. So we're looking at our X's. We have 7, -3, 1, 3, and 2. So my domain of my set, my brace just got real weird right there. It doesn't matter as long as it's in some order. I'm going to start with low. So I have -3, then I have 1, then I have 2, then I have 3, then I have 7. And that's my domain set. Agreed? You're going to do the same for the range. So for my range, I'm now looking at my Y's. Okay, notice that this time I have 2 5s. Do I write them twice? No, you do not. You only list it out once. So what is my smallest Y value? -4, then that takes me 2. And then 5 and 6. Okay, so when you have a discrete data set, which is usually a table, a ordered pairs, a mapping, you are listing out your domain. Make sense? For the mapping, yeah. Okay, because of this, did any of my X values repeat? No, so does this represent a function? Yes, so this is a function. Yep, whether it's a function or not depends on your domain. All right, do the mapping. All right, so on the mapping here, it was conveniently already listed for us. Here's our X, here's our Y. When you look at your mapping, there are 2 lines coming off of the 2. So what does that tell me automatically? It's not a function. It's not a function because my X value is doing what? Repeating. My X value is repeating. Okay. Yes, you still only write once. Yes. But to answer the not a function part. So your domain again is fine. It has been. It doesn't want me to be great, and y'all already know that I make horrible braces. My braces are on the struggle bus. Don't judge. Yeah, you get it. You get it. What's happening. All right. Now, this is again called what kind of data set? Discrete. Discrete data. Okay. It's very specific. Now we're going to look at examples of continuous. I think my function thing isn't loading. Maybe that's what it is.
What?
I'll look at it while I do this. All right, so these are continuous functions, okay? That means they either go forever to the left and forever to the right, or one or the other, correct? So when we're looking at that, we're describing the domain and range. You're asking yourself for your domain, how far left do I go? How far right do I go? Ringing some bells? All right, so when I look here, the domain of this function, how far to the left do I go? -4. It is included. So you remember the bracket, it means it's included. And then how far to the right do I go? Forever. Okay. And parentheses can't be contained. So it's always going to be infinity can't be contained. So it's going to always be a parentheses. Okay. The other way that you can write this is with inequalities. So with your inequalities, you're saying that your X values are greater than or equal to -4. Yes? Now we're going to do our range. So your range is from bottom to top. So our lowest y value is -2, and it's included because it's a closed circle. And then it continues to infinity and beyond. Okay, I can shorthand write this using inequalities. Yes. It's a bracket because it's a closed circle. It's included. And it's a parenthesis because you can't stop or include infinity. So we have y is greater than or equal to -2. Yes?
Inequalities, because they're like a longer way to write it, like x is greater than or equal to infinity.
Yes. You would write, I'm going to write on the side for you, August. So x is less than or equal to infinity, but greater than or equal to -4 is the long way of writing the inequality. Your left, what is your left doing? What is your right doing? Yes. Your y's are getting bigger. Mhm. All right, D is an example of a continuous function, but with a what in it? Has a couple things happening, right? It has asymptotes and it has a hole. Do you see that hole in the function? Okay, so we have a hole and an asymptote. So that means it's going to cause some little hiccups in our definition. Yes. Oh, it's a function. It's a square root function. Does it pass the vertical line test? Yeah. Does it pass the vertical line test? The vertical line test is a visual check of whether a given relation is a function. Meaning that if I had a straight line, do I hit more than one point at a time? VLT. Yeah. All right, so here, domain. So our domain, we're going to start from the furthest left. So from the furthest left, I'm going forever to what? Negative infinity. I'm traveling along, like, uh-oh, what's wrong? I have to stop at where x is. So we're looking at the x value. I have to stop at 2 because there is a hole in my graph. So that is a stop. And because there's a hole, it is not included. So I put a parenthesis. All right. Do you guys remember the U? That means I'm now going to resume and we go back on our journey. So after we go, we're like, do. So we leave from 2 and then, uh-oh, what happens? I have to stop. Why do I have to stop? There's an asymptote. There's an asymptote. Okay. So there's an asymptote in my graph. That asymptote happens at what x value? 4. So I have to stop. Then I'm going to resume. And now I keep going. Is there any more things stopping my x's? No. So it continues to infinity. That is the complete situation of your journey. Starting from left to right. Okay. These bumps along the way are called discontinuities. What are things that make you discontinuous, right? All right. Sorry. That's a conversation for therapy. So let's continue.
I was gonna say something, but
All right. Here we go. Range. Range is from bottom to top. So at the very bottom, where is it heading? Towards negative infinity. Okay. As we rise, we're going. Then, oh no. What do we see? Asymptote, a horizontal asymptote. And where's that horizontal asymptote at? -2. So it makes me stop. And then I'm going to resume from -2. Then I'm going again. Mind my business. Oh no. There's a hole. Where do I stop? On the Y. I stop at 5. And I'm going to resume after 5. And then we continue to infinity.
oh, okay, never mind.
Are you good? Okay.
Oh, I understand now.
Do we see how we traveled? This would be the most extended version of writing a domain and range you should be okay doing. Yes? Okay. I'm going to, yes. Huh? Oh, it's a function. Why is it a function? It passes the vertical line test. All right. What is our equation on E? F of x equals x squared. Thank you. F of x equals x squared plus 3x, like that. All right, so if I have f of x squared plus 3x, and I don't have any other way of graphing this, the only other thing I could do is create a table, right? I could create a table to be able to graph it if I didn't have a graphing utility. Does that make sense? I would create a table to figure out where things lie on this graph. Makes it? So, it's a, what kind of function? It's continuous, but what is my parent function? X squared. It's an x squared, so it's a quadratic. So I know that this is a quadratic. We should be able to identify quadratics, leaving algebra 2. This is a quadratic, which means that my shape is going to be a parabola, correct? We're not going to adhere to her nonsense, okay? So we're going to create some. So you have a couple skills you could use here. You could find your zeros, correct? Figure out where it is across the x-axis. You can figure out just making a table. Does anyone remember how to find my x-intercepts from a quadratic?
I remember doing it.
Oh, man.
No.
Oh, Joe.
No. You factor and set each factor equal to 0. Does that ring a little bit of a bell? Yeah, so this is a simple factor, it's a GCF. So you factor out x and you're left with x plus 3. And if you set this equal to 0, you know where your x-intercepts are. So x equals 0 means that you have an x-intercept at 0. And x plus 3 equals 0. What would x have to be in order for this to equal 0? -3. So your other 0 is at -3. So are we okay with the factoring? Are we okay with, just first question, are you okay with how I factored? That's why I just asked, are you okay with how we factored? Okay, that's what I was asking. GCF, what is the greatest common factor between this term and that term? So what did I factor out? X. So I factored out the x. When you're looking for your x-intercepts from a quadratic, you're taking each factor and you're mentally setting it equal to 0. Well, my first factor is x equals 0. My next factor is x plus 3 equals 0. Well, x equals 0 means that you have a 0 at 0. And then x plus 3, what would make this a true statement? -3. So your other 0's at -3. Does that make sense? Yeah? Like for real. Tell me if not. So therefore, you now have an idea of where your numbers lie. Yes? So you know that at -3, you're at 0, and at 0, you're at 0. So all you need to do is find -2 and -1 to get an idea of what your graph is doing. Yes? Remember the function notation we just practiced? That way. Yeah. So what is -2 and -1? Either one, the factored form or the original. So if you substitute -2 in, what do you get? Substitute -1 in, what do you get?
Wait, I just found.
-2 squared is?
Oh, it's
What is -2 squared? 4. What is 3 times -2? -6. 4 minus 6 is? Huh? -4 minus 6 is? -2.
Yeah.
So you know that at -2, it goes down here too.
Okay.
All you're doing is substituting. And then negative 1 squared is 1. 3 times negative 1 is negative. And 1 minus 3 is negative 2. So your graph is doing something to this like so.
My teacher didn't teach me how to do it.
That's cool.
That worked.
I spent like 5 weeks on quadratics. I really don't know what to tell you.
So we don't have to put the domain in range if we have the X and Y values.
No, you're gonna state that. Now you can state the domain in range. What's your domain? Goes forever to the left, forever to the right. Your domain is negative infinity to infinity and beyond. What is your range?
Probably negative two. Probably negative 2 to infinity.
Probably like a little lower.
Like,
It's like negative.
5.78.
It's all the way down here somewhere.
Negative 1.2.
negative
Can we
2.5.
just put NB?
We'll talk about doing the real thing. We'll go to negative. To find it, you're just gonna you just plug in negative 1.5. Y'all were stressing about plugging in negative 1 and negative 2, so I didn't want to throw the decimal out there at you quite yet.
How do you know this is a function?
Yeah, 11:30, right? Can we be real?
Vertical line test.
Remember how that works?
What's the vertical line?
Yes, here you go. Here we go. Here we go. Ready? If I draw a vertical line at any point, do I hit more than one point at a time? So therefore, this
I
is
asked
a
him what rock
function.
hard
Vertical line. No, but we only said that because I answered you 3 times about it, and that's why we were confused. Yeah, no, you're good. You're good. All right. So on the next one is going to be for you guys to do. It's a square root function. So it's the square root of 4 minus 2x. You're going to build a table, and you can just start from any value. It has no special treats. The key. Oh, yes, it does. Sorry, I lied to you. What cannot be underneath the square root? F of x equals 4 minus 2x, right? What can't be underneath the square root? No. Oh, no. No. A negative. It can't be a negative. So your starting point depends on when 4 minus 2x is greater than or equal to 0. That's how you know where your table starts. Does that make sense? Because you can't have a negative. So you figure that out, then you know where your table begins. Get x by itself? How would you get x by itself? You're just solving this 2-stepper right here, guys. What do you need to do to get x by itself? No. What do we need to do to get x by itself?
5.
Minus the 4. That's what I was looking for. Yeah. We all heard her. You need a minus the 4, like 2-step, you know. Minus 4, we're left with negative 2x is greater than or equal to negative 4. Then what do I need to do? Divide by negative 2. And that gives me 2. So the starting point of my table is at 2. And therefore 2 starts at 0 because what were we solving with?
X.
Well, what did we start with? 0. And then now you can choose whatever number, but you now know that you start at 2, 0. So you can do 3, 4, whatever numbers you want. And then you can graph it from there, determine whether it's a function and state the range. Why is it not a function?
What time is this class at 11:30? Ah, yes, we're close to ending time. And so I literally feel like I could get this one, let me really get on it.
Yes.
How do we
feel like
plug them
that's-
in if we can't, if you can't have a negative?
These are the numbers you start at. What comes after two?
I'm saying,
Plug in three.
I'm saying, but it gives me an error because you can't square root of negative.
I'm gonna start meal prep. I'm gonna eat tuna. Chicken.
Yeah, I'm a little confused. Oh, I went the wrong way.
What's it?
Go the, yeah, don't go that way. It'll be 1, 0. Yeah. Yeah, sorry. What? You're going left.
You should get the one
Yes.
fifty.
No. What? No, you're not an idiot at all. You're going to the left. So 2, 1, 0, -1, -2. Because if you go to the right, that's what makes our negatives.
And so we plug that into which?
The
That
original.
one? Okay.
So you're going to the,
Okay.
yeah, sorry. So 2, 1, 0, that way. And I will too. For letting you go with the past.
Oh, it's 100%. Like it's like 3 times. It takes like 6 grams per second.
I'm not saying I'm gonna go.
Tuna is like double that. Well, the ratio, I mean.
I just have.
That's why,
Yeah.
that's why I'll eat both. I'll eat hard boiled with eggs and tuna. And I'll probably get some turkey or some grilled chicken, with rice. But always been variation. Variation is really good. And then every once in a while, I'll probably make me a PB&J, just call it egg.
Well, your graph is your the graph. The X is. What is this?
It's really bad. Too much of anything's bad for you.
I'm gonna give
Even
you
if
all
it's too much
minutes,
protein.
right?
You always need your carbs.
Right.
Good
Yeah, we know.
carbs. Mixed nuts are so good because they have a bunch of good fats. And good protein. Are we?
I mean, you can estimate like 1.5.
What's wrong?
Well, let's do the next one. So get another one that you form a solid number. So don't get stuck on the fact that you don't get screwed. You have try another
Are we
number.
doing this one?
A number you can work with.
Who got this?
We're passing them.
And we're gonna start off strong, right?
Wait, does the line that we're drawing, does it start at a point in the line or does it just go both places?
This is around.
It should keep going.
We should have timer on homework. So which point does it start
Same
at
thing.
2-0? You're right. Does it start at 2-0?
It starts at 2, 0. So my first point that I have is 2, 0. Next, I'm gonna plug in 1. Well, when I plug in 1, that gives me 4 minus 2 is 2. So I'm left with the square root of 2. I can't graph square root of 2 without knowing the exact value. So I'm gonna go on to 0. I plug in 0 and I get square root of 4. What's the square root of 4? 2. So I know that 0 is at 2. Does that make sense? All right. So now we have -1. -1, plug that in. -2 times -1 is 2. 4 minus 2 is going to give me 2. Does it give me 2? No, it's plus. Sorry. A negative times a negative is a positive. So I'm left with the square root of 6. Can I graph that? No. So I'm going to go on to -2. I now have -2 times -2 is 4. 4 plus 4 is 8. So it just keeps going. So as I'm looking, I can see a pattern. I can see that my graph is just keep going and going and going. And that is the way it's heading. Now that I have a general idea of where it's going, I can state the domain. What is your domain doing? Well, my domain, other way around, -infinity to 2. Left to right. Even though it's going there, you read it from left to right. That's why we're doing it and reviewing it. Your range, bottom to top. Range starts at 0 and then it keeps getting bigger. And is it a function? Our range is growing. Our y values are steadily getting bigger and bigger.
What does it do? Did you put
Yeah.
negative?
Is our two in a bracket or?
Our 2 is in a bracket because there's a value there. Friday. Your assignment is due Friday. You can drop it off in class or you can submit it on Canvas on Friday. Okay. I take it however you give it to me.
Yeah, okay, good luck with that.
Alberto, let's do it together.
I'm not gonna do this together.
Please, Alberto.
Trying to take a fat nap. Trying to do the word. Work is for home. It's home. Oh, yeah.
Well, to be honest, I'll be with fishy, you know. I got.
Okay, well,
There you go.
What?
2 hours.
I might go some.
But you do that.
Start next week.
the last part of our notes is talking about intervals of increase and decrease. And when we're reading our graphs, we want to make sure that we're reading from left to right, just like you read a book. And that's because you're looking to see where your graph rises from the left to the right on the interval. So you're describing what's taking place, okay? When you are describing, you're only referring to your x value, okay? We're not asking what's happening with the y's. When you're describing intervals of increase, decrease, and constant, you're only using the, what did I just say? Your x. Thank you, Randy. Let's try that again. When you're describing intervals of increase, decrease, and constant, you're only using the x. You're only using your x values, okay? So these are just the technical definitions of when an interval is increasing and decreasing. So you can read those later, but basically it's just saying that if I'm increasing, as my x values are getting larger, so are my y values. Does that make sense? When I'm decreasing, as my x values get larger, my y values are decreasing, getting smaller, okay? And I'm constant, as my x values are changing, there's no change happening to my y values, yes? All right, that's all that these are basically telling you. Just key thing to remember, we read our graph in mathematics from left to right, the same way we read our book, got it? All right, so you guys, just for the sake of time, I kept the highlighted stuff. So as you can see right here, before I did the answering, I went through and I marked my graph, starting from left to right. So on the left side, I highlighted it in red because that's where I was decreasing. You don't have to mark it. You can write A, this is a decreasing interval. As I keep reading, I now am doing what? Increasing. As I keep going, now what am I doing? Constant. As I keep going, what am I doing? Decreasing. So when I come to the problem and it asks me, what interval am I increasing or decreasing on? I already have it labeled on my graph. Does that make sense? So here, increasing. How many intervals of increase do I have? 1. So I'm only going to write down that one interval of increase. So when I'm writing down the interval of increase, again, which value am I only looking at? I know, but what value am I looking at? The x, only using your x values, okay? So when I come here for my green starts at 0 and it ends at 2. So my interval of increase is from 0 to 2. Okay? And you need to be comfortable seeing it in either format, whether as 0 to 2 or in interval notation. Always left to right. Okay? All right, next is our decrease. How many spots of decrease did we have? 2. So how many intervals should I have listed? 2. So my first one starts from negative infinity and comes all the way up to, where would it stop at? No. What is the x value? 0. It goes from negative infinity and stops at 0 because we only look at the x value. So that's why I have my first intervals from negative infinity to 0. Yes? All right. Then it says that we have our what do you call it? Next one, our second one. And it starts where? Starts here at 5. Not at 2, but at 5, because this ordered pair is 5, comma 2. It's 5, and then it continues forever to the right, and forever to the right is infinity, positive infinity. So it's from 5 to positive infinity. Okay, how many intervals of constant do I have? Just one, right? The yellow, I only have one interval of constant. And where does it start? At x equals 2. And where does it end? At x equals 5. So my interval of constant is from 2 to 5. Okay. Tying back to what we just finished doing, what is the domain here? Negative infinity, infinity, because it goes forever to the left and forever to the right. And my range is also negative infinity, infinity, because it forever is decreasing and forever increasing on its ends, correct?
Barely. Yeah. Good job. Thank you.
All right. And then notice that when we're describing intervals of increase and decrease, we are using what? Our x values, and we want to make sure we use parentheses. Now, there was a debate at my AP class that I had this summer on whether they're looking for brackets or parentheses. And if it changes from parentheses to brackets, I will let y'all know for intervals of increase, decrease, and constant. Okay. Got it? All right. First note's done. Yes. Page 1 is done.
How long?
Not very long.